For this section, we're going to be talking about variable notation. We're going to kind of go over how you can show that two different statements are equal or not equal. We're going to talk about identifying the different parts of a linear equation, like what the terms would be, the factors, constants, variables, those kind of things. So I want to go over first like what an equation is. So a basic equation is just a symbolic statement that two expressions or quantities are equal in value, and an equation can be true or false. So there are some cases out there where when you go to solve it, your variables end up maybe canceling out, and you end up with a statement that says 3 equals 5, which would not be true, and so that would be a situation where there's no solution. So just because you have an equation doesn't necessarily mean that there's always an answer. But most of the time, you're going to be able to solve the equation for a specific number, but some of those cases are out there. In order for you to verify that an equation is true, you need to try to simplify both sides as much as you can and make sure that they equal each other. So you want it to just be a true statement. So you want to just compare the values for each side. If they are equal, then that means that it's true, and in that case, that if they're not equal, then it would not be true. So we're going to start by just verifying that these statements are true equations. And so all I mean is actually just show that the left side and the right side equal each other. So for this first one, you've got 3 parentheses 8 equals 24. Well, 3 times 8, if we actually did that, we would get 24. And so this is a true statement because 24 is going to equal itself. For the second one, we have to just evaluate both sides. So 12 minus 3 is going to be 9. And 2 plus 7 is also going to be 9. So there, again, we see that it's the same thing on both sides. Now, to solve something would be to find the missing number that makes the equation true, and this is when variables can sometimes come in. Variables are letters that are used to represent the unknown, so the thing that you're either missing or you're trying to find in an equation. So for example here, we're going to find the value of the variable that makes these equations true. So this first one, we have x equals 3 plus 8. So I'm just going to add 8 and that 3, and I get 11. So x would equal 11 for that first one. For the second one, I need to take 18 and divide by 3, and that's going to be 6. So we have 6 equals n, and you can always rewrite this too so that the variable comes first and then your number. A lot of times people like to rewrite it because that's normally how we see it. It makes a little bit more sense to us just read it that way, the letter first and then the number. For the last one, follow your order of operations. So the first thing you need to do is multiply the 3 and the 4 and you get 12. And then you subtract the 5. And you're going to get 7. So y equals 7 for that last one there. So we have a couple of properties here. This first one is the symmetric property of equality. And what that says is that if the sides of an equation are interchanged, equality is maintained. So if I can look at either side of an equation, and they could be flip-flopped or they could be switched around, but they still remains to be a true statement, then that just means that I'm using that symmetric property. Symbolically, they show you A equals B and then B equals A. So you can just kind of flip them around. It's not going to change the meaning of that equation. Factors are numbers or variables that are multiplied. So we've talked about factors before when we were doing like our factor trees. And this was when you were trying to find numbers that multiply to the number that you were working with. So factors are just any things that are multiplied together to get to a new number. So like 2 and 3 would be factors of 6 because 2 times 3 equals 6. Terms are algebraic expressions that are single quantities or products or quotients of quantities. So a term could look something like just a 5, or it could even be something like 2x, or it could be n divided by 5, or it could be even like xyz. Something like that could be considered a term. Terms are going to be separated by either an addition or a subtraction sign. So they all will have either a plus or a minus sign in between them that kind of separates them out. And the sign of each term is the sign that precedes the term. So if there's a positive sign in front of it, that means that that term would be positive. If there is a minus sign in front of your term, so if it says like minus 2x, 2x then would be negative. So what they want us to do here is identify the terms by highlighting each term. You guys could underline it, and if you're underlining it, do it with different amounts. So like underline one of them one time and another term like 2 times. Or you could use different shapes to circle. You could use a circle, triangle, square, something like that. So 3x would be considered a term, and 5 would be considered a separate term. For this next one, the 2ab is a term, 4a is a term, the negative b is a third term, and the last term would be this 2 plus a plus b. So each one of those is a separate term because they're all separated by a plus or minus sign. For letter C, it's just one big term. So this whole thing is just one large term. Now, if it had been separated into 2 separate pieces here, then you would have 2 terms. Similar like to letter D. Letter D has 2 terms. You have 2a over the 3, and then you have 1. So if the terms are separated by a big sign, like this one has the plus sign in between those 2 terms, that's what separates them and makes this one have 2. Where this one had a plus sign just in the numerator, it doesn't divide that 3 out, so that's why that one just has 1 term. A constant would be a term that contains only a number, so it would just be like a 5, a 10, a 17, it's just a plain number by itself, it doesn't have any letters. The variable term would be the combination of letters and numbers, so it could just be a letter, like x or y, or it could be something like 2x, 3y, something like that could be considered a variable. So constants, like I said, are just numbers, like 3, 5, 10. Variables could be something like x, 2y, 3ab, something like that. The coefficient would be the numerical factor of the term. So if you had something that said 7y, 7 would be considered the coefficient because it's sitting in front of the letter. So to identify the numerical coefficient of a term, since terms contain only factors, the coefficient is the number or the product of all the numerical factors. So if you had multiple numbers in front, you'd want to multiply them. If the term is a fraction, then the number would be the numerator piece over the denominator piece. So if it's a fraction like 1/3, that could also be considered a coefficient. For example, here on this first one, they just want us to identify the numerical coefficient. So this first one says 2x, so 2. B would be just the negative 3. For this one, if I were to actually distribute, it would say 4x plus 3. The coefficient is only the term that's sitting in front of the letter, so it would just be the 4. So 4 would be the coefficient. For D, think about what number would technically be in front of the n. There's technically a 1 there. So this would be like negative 1/3 n. So your coefficient is going to be that number, which is going to be negative 1/3. And then for E, again, it's similar to D. You just see the numbers this time. So you could pull it out. So it's 2/5 B. So the coefficient is going to be that 2/5. So coefficients are just the numbers that are sitting in front of those terms that have letters involved. Another thing that we can do is write out verbal interpretations. So if we see an equation, we can actually write out a sentence that describes what's happening here. The thing that I tell students when they're doing this is to just literally read out loud or think to yourself in your head, what does that say? And then write down what you thought it said. Because that is the best way for you to write out the expression. It doesn't have to be anything fancy. You can use simple terms. You can also use as fancy as terms as you would like to. You don't have to just say plus or minus or times. You can say the product of or the sum of or something like that if you want to. So for this first one, if I read it, it would say x minus 7 equals 4. Instead of saying x, I'm going to call x like a number because I don't know what it is. And so if I was reading a sentence that said a number in it, I would know then, oh, that's my variable. That's what I'm going to put the letter in for. And you can choose multiple letters. It doesn't have to be an X. It could have been a Q. But for this one, instead of saying X, I'm going to want you guys to say a number. So I would say a number. And you could say subtract 7 minus 7. Equals, or you could say is 4. For number 2, we could say a number divided by 5 is 3. You could have said the quotient of a number in 5. That would be the same thing as saying a number divided by 5. Quotient means division. So the nice thing about some of these is that there are multiple ways to write out your sentence. So you could use a different terminology than someone else next to you, and that doesn't make either of you wrong necessarily. As long as you're using the right terms, either one should be okay. Now, for these more complicated ones here, when you've got a little bit more than just a letter and a number, again, just kind of read it out loud, what you see, and then try to translate that into terms. So like for number 3, it says 2x plus 3 equals 15. Instead of saying 2x, 2 and x are being multiplied. So you could say 2 times a number, or the product of 2 and a number, or you could say twice a number. So if we wanted to write out a sentence, you could say twice a number that takes care of the 2x. Now we have plus 3 is 15. For number 4, it's written a little differently than number 3. For number 3, it was 2x plus 3. This one is 2 times the whole quantity, x plus 3. So a little bit different here in how we're going to write this. So what I'm going to say for this one is it's twice, and I'm going to say the sum of a number and 3. Is 14. Okay, so the twice is the 2 times the whole quantity. And since I say the sum of, that means that I'm adding that letter x, a number, and the 3 first before I multiply. So I said it differently. Instead of saying like twice a number plus 3, which would be what number 3 said, since I'm saying it's twice the sum of, that kind of lets the reader know that I have to add those 2 terms first before I multiply by the 2. If we think about order of operations here for 3 and for 4, your first thing that you would do if you knew what x was, is you would do the parentheses. You would take 2, or you would take x plus the 3 first and then multiply by 2. So that's why they're written a little bit differently there, is because technically they do say a little bit different things because they have different order of operations happening. The other thing that we can do is go the other way. So instead of us writing out the sentence, we want to write out the equation based off of the sentence. So this one says the sum of 12, 23, and a third number is 52. So let's kind of break this down a little bit. Sum, that word means plus. So you're adding things here. Now there are two numbers. There's a 12 and a 23, and then there's a third number that we don't know. So this is the unknown. This is the variable. So I'm going to do 12 plus 23 plus some third number. So we could call it X, we could call it N, we could call it W, whatever letter you want. Is always a word for equals 52. So that would be the equation. Number 2 says, when a number is subtracted from 45, the result is 17. So when a number is the variable, subtracted from, okay, so we have a subtraction operation happening here. Now it's coming from 45. That means that you started with 45 first, and then you took away the number. So don't get that backwards, because I see a lot of times students will want to write n or x minus 45, when it really should be 45 minus, like your x or your n, whatever letter you want to use. Then it says the result is 17. So is, again, is that keyword for equals, and then we have 17. This third one is asking us to solve the problem. It says how many shelves that are each 3 feet long can be made from a board that is 12 feet long. So we have a total of 12 feet, and we're basically trying to divide up this 12 feet so that each shelf is 3 feet long. So I'm going to take 12 divided by 3. This is going to be like the number of boards or the number of shelves that I can make, so it's going to equal x. So if I actually take 12 and divide by 3, I get 4. So my answer is going to be 4. 4 shelves could be made. Okay, so for this next one, they want us to explain the difference between these two statements. A says 4 times the difference between a number and 8. So this is really similar. If we kind of scroll back up here for a second, where was that at? This one, right here. This is going to be kind of illustrating what happened here. So 4 times the difference. So we're taking 4 times the difference of a whole quantity. So we're going to have something in parentheses here. So difference is subtraction, and it says between a number and 8. So we're taking like the number n or x, whatever letter you want to use, and we're subtracting 8 from it. And that's going to equal 24. The second one is the difference between 4 times a number and 8 is 24. So the main difference here is that the first one, we're taking 4 times this whole quantity, where on the second one, we're only taking 4 times the variable. So if I had to explain that out, I would just write that out in words and say, for the first one, 4 is being multiplied by the whole quantity, n minus 8, while on the second one, 4 is only being multiplied to the variable. And that would explain the true difference between those two equations and why they're a little bit different. Okay, so next what we can do is simplify variable expressions. So this is when you've got a really big sentence, but you see some common terms, and you're trying to simplify it by getting those common terms together. So these are called like terms. Like terms are terms that have the exact same letter or number factors. So if they are just plain numbers, so if they're just like a 5 or they're just a 6 or something like that, you can combine those. But if you start having letters involved, like X's and Y's or A's and B's, you can only combine terms that have the same letter or the same combination of letters. So if you had like 2X and 3X and a 5Y, you could only combine the X's. You can't combine the Y with it. That could also be like if you had a 2XY and a 5XY. You can combine those because they both have an XY. But if you were trying to combine it with something that just had an X or just had a Y or had even like an XYZ, if they're not exactly the same, then you can't combine them. For example, if I have 5A plus 2A minus A, remember that minus A technically has a 1 sitting in front of it. So I'm taking 5 plus 2A, this would be a 7A, and then I'm subtracting 1 A. So 7 minus 1 is going to leave me with 6A. For this next one, we've got a couple of different like terms. So you can either underline like terms, or I've seen kids like circle them with different shapes to kind of keep them separated. What I'm going to see here is I've got 3x and a negative 2x. Make sure that you watch the sign and sitting in front of that term. I have a 5y and a positive y. And then I have an 8 and a negative 12. So 3x and a negative 2x. 3 minus 2 would be 1x. So 1x, where you could write just x. You don't technically need the 1. 5y plus y. Again, this has a 1 sitting in front, so 5 plus 1 would be 6. So x plus 6y. And then 8 minus 12 is going to be negative 4. So that would be the simplified form. Last thing we're going to cover here is the distributive property. Distributive property is when you have that number sitting outside front and you're multiplying it in. So you're taking 3, and I always draw my arrows so I don't forget to multiply to all the terms. So you take 3 times 5x and 3 times the negative 2. So 3 times 5x is going to be 15x. 3 times the negative 2 is going to be negative 6. If I look at the second one, I need to take negative 7 times everything. So that says negative 7x, negative 7y. And now negative 7 times negative 3 is going to make that last one become positive 21z. The last one here, you've got a negative in front of the parentheses. So this is like negative 1, and I'm trying to multiply it. All it's going to do is change the signs of the terms on the inside, because 1 is not going to affect them, but because it's negative, it's just going to switch their signs. So negative 1 times negative 3x is going to make it become positive 3x. And then negative 1 times 4 is going to make it become minus 4. So we have 3x minus 4 for the final answer there. And that is the end of this section. So I'm going to end it here. And if you have any questions on this, please let me know.